Now we see about the classification of ensemble. There are three types of ensembles. That is the first one, the microcanonical ensemble. Second one, the canonical ensemble. The third one is the grand canonical ensemble. So now we see about this microcanonical ensemble. So in the microcanonical ensemble, you are seeing the different independent systems. The systems are found to be independent with one another, but the energy, volume as well as the number of particles in a particular system remains the same. And these independent systems are separated by rigid, impermeable. What is this impermeable? Impermeable means not penetrating. Okay. So rigid, impermeable and well insulated walls. So that the energy, volume and number of particles in a particular system is not affected by the other systems. So it has independent system having the same energy, volume and number of particles. Because of this rigid, impermeable and well insulated walls, the particular system is not affected by the other system. Such an ensemble we are calling that as microcanonical ensemble. And now we see about this canonical ensemble. Under canonical ensemble, it is a collection of independent system having same temperature T, volume V and number of identical particles N. So here you are seeing the independent particles having same T, V and N, but they are separated by rigid, impermeable conducting walls. Actually the system has to be in thermal contact with a large heat reservoir which is maintained at a constant temperature T, or otherwise each and every system has to be in thermal contact with one another, but the temperature has to be constant throughout. Since the walls are conducting, the temperature heat exchange takes place between the systems and the temperature remains constant. But in this canonical ensemble, the system can exchange energy alone but not matter. Matter means the particles cannot be exchanged between the independent systems, since the walls are found to be rigid and impermeable. Impermeable means not able to penetrate through the other system. But so that exchange of heat alone takes place, and since they are in thermal contact with one another, a constant temperature is maintained throughout the system. In all the independent system, the temperature T remains constant. The last one, it is the grand canonical ensemble. So the grand canonical ensemble, it is a collection of large number of independent systems but having same temperature T, volume V and chemical potential mu. So mu is nothing but it represents the chemical potential. And here you can see the walls are found to be rigid, permeable and conducting walls. Since the walls are permeable, the system can exchange particles also, and the walls are conducting, the temperature heat exchange can take place between the system and the temperature T remains constant throughout. So in this grand canonical, the speciality is the system can exchange energy. The system can exchange both energy as well as matter can be exchanged. Okay, so the system can exchange energy but also matter, but matter also can be exchanged in this. So as a summary, we will see this in microcanonical, neither energy nor matter is exchanged. So energy as well as matter cannot be exchanged in the case of microcanonical ensemble, because the walls are found to be rigid, impermeable and insulating walls. But in the canonical, you can see energy is exchanged but not matter because of the rigid, impermeable walls, but energy can be transferred because of the conducting walls. In grand canonical ensemble, both energy and matter is exchanged because the walls are found to be rigid, permeable and conducting. Since it is permeable, the particles can penetrate through the other system as well as it is conducting, so the temperature remains constant because of the transfer of heat from one system to another system takes place.